Okay, so today we're going to talk about parallelograms. We're going to talk primarily about the properties of parallelograms. Um, as you look around the room, we have a number of parallelograms in the room around us. If you look up on the walls, the posters up there, those are what we would consider to be parallelograms. You might more specifically think of them as rectangles. If you look at the ceiling, we've got squares up on the ceiling tiles. Those would also be considered parallelograms. And you're going to see here in just a minute why we can consider those parallelograms. So let's go to our first slide here and talk about our objectives, what we're going to be doing today. We're going to be proving and applying the properties of parallelograms, and then you're going to use the properties then to be able to solve some problems within this lesson. Okay, on this next slide, we've got a list here of some of the shapes that we consider to be quadrilaterals. This chapter deals with quadrilaterals, which quadrilaterals just simply means any shape that's enclosed with four sides. These are some of the specific ones that we're going to study: the rhombus, the square, the rectangle, the kite, and trapezoid. So hopefully you're somewhat familiar with what those shapes look like. And we're going to, like I say, if you don't, as we go through them, you'll be able to kind of pick up on that, I hope. Let's start with our main definition of a parallelogram and our first property. Again, you're going to want to write down there are 5 properties to a parallelogram that we're going to focus on. This first one says a quadrilateral with 2 pairs of parallel sides is considered a parallelogram. Again, we use this little symbol. Just basically, it's a little picture of a parallelogram to represent that. We use 4 letters, A, B, C, D in this case, kind of go around the shape. Notice, just like when we talked about our lesson on parallel lines, these little arrows on the opposite sides indicate that those lines are parallel. So if AB is parallel to CD and BC is parallel to AD, then we can state that this is a parallelogram. Let's go ahead and go on to our next slide. So property number 2. So if a quadrilateral is a parallelogram, then we know that the opposite sides are congruent. So not only are the opposite sides parallel, but the opposite sides are going to be congruent to each other. So in this figure here, AB would be congruent to CD, and BC would be congruent to AD. Again, we mark those. They're already marked as parallel. But we could mark them to show that the sides are also congruent. So property number 2, opposite sides are congruent. Okay, let's go ahead and move on to the next slide. The next slide has our remaining 3 properties on it in a little chart here. So property number 3 says if a quadrilateral is a parallelogram, then we know the opposite angles are congruent. So notice in this picture, angle A would be congruent to angle C, and angle B would be congruent to angle D. So again, the opposite, when we say opposite, the angles that are diagonal of each other are going to be the same measure. Property number 4 says this: if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. Hopefully you remember from our parallel lines unit what it means for angles to be consecutive. So in this picture, we could say there really are four sets of these. A and B would be supplementary. Those are same side interior angles. B and C, those are same side interior. C and D, and A and D, or D and A. Again, those are going to be supplementary. Then our last property says if it's a parallelogram, then the diagonals bisect each other. So what that means in this picture is that AZ is going to be the same length as CZ, and BZ is going to be the same length as DZ. So if I were going to summarize the 5 properties, these are the 5 properties that you want to make sure you have written down right now in your notes. Number 1, opposite sides are parallel. Number 2, opposite sides are congruent. Number 3, opposite angles are congruent. Number 4, consecutive angles are supplementary. And number 5, the diagonals bisect each other. That's kind of the shortened version of what's in that chart and what was on the previous slide. So here's what it says. It says in parallelogram CDEF, DE is 74. So again, I'm just going to fill in this information. You may want to go ahead and draw the picture here. And as I said, we're going to use the same picture for the next few problems, so you won't have to redraw it. We're saying that DG is 31 millimeters, and we're saying that angle FCD is 42 degrees. So that angle is 42, and they want us to find the measure of side CF. Yeah. So on this one, we would say that CF is 74. As he said, the opposite sides we know are the same length. They're congruent to each other. Okay, let's do another question related to that same picture. They're still telling us that DE is 74, that DG is 31, bottom angle is 42. We've already said that CF is 74. Now they want to know what's the measure of angle EFC. For us to find the measure of EFC, we're going to do 180 minus 42. Well, 180 minus 42 is 138. So on this one, remember we still know that DE is 74. We still know that DG is 31. We said this is 42 degrees. We already found this angle to be 138. Now they want us to find what's the length of DF. In other words, what's the length of that diagonal? So we know since the diagonals bisect each other, 31, this will also be 31, so we just do 31 plus 31. So the length of DF is going to be 62. So now we're going to do a little application and do a little bit of algebra. Still applying our 5 properties that we just talked about. So WXYZ is a parallelogram. We want to find what's the length of YZ. So as I look at this picture, I know that WX and YZ have to be the same. So for this first one, I'm going to say 6A plus 10 equals 8A minus 4. Yes. As we look at our equation, we're going to subtract 6A. We get 10 equals 2A minus 4. If I add 4 to both sides, 2A equals 14. If I divide by 2, A is going to be 7. Again, they're wanting to know the length of YZ. So I'm going to take that 7 and I'm going to put it right back in here for A. So 8 times 7, which is 56, minus 4, tells me that YZ is going to be 52. So to find the measure of angle Z, we're going to say 18B minus 11 plus 9B plus 2 equals 180. If I combine my terms, 18B and 9B is 27B. Negative 11 plus 2 is negative 9. I'm going to add 9 to both sides. So 27B equals 189. I type into my calculator 189 divided by 27. B is also going to be 7. And then I'm going to take that 7 and plug it back in right up here. So 9 times 7 plus 2, well, that's 63 plus 2, which is 65 degrees. Okay, hopefully for the first one, again, we're utilizing the fact that the diagonals bisect each other. So to find JG, we have to first of all find W. So 3W equals W plus 8. And if you solve for W, you get 2W equals 8. And then divide by 2, so W is going to be 4. To find JG, I just plug 4 back in. So 4 plus 8, JG is going to be 12. Once I set those two parts equal to each other and go ahead and solve, I'm going to, if I subtract 2Z from each side, I'm going to do 2 steps in one. I'm also going to add 9 to both sides. I get 2Z equals 9. And if I divide by 2, Z is going to be 4.5. So again, I'm plugging Z back in. 2 times 4.5 is 9. That's half the diagonal. So if I take that times 2, the diagonal FH would have to be 18.